Okay, tonight's chapter is about correlation analysis. If there are two variables, independent and dependent variable, then find the relationship between two variables. That is correlation analysis. The study of a relationship between variables, it is also defined as group of techniques to measure the association between two variables. Okay, variables, dependent and independent, as you know. If there are two variables like sales, cost, and then cost sold, more sales. Now we can expect like this. Sales call more and more. Then we can expect the copiers sold, the number of copier sales increase. So sales call more. So move this one first. Then later this one follow. So X variable move first, and then Y variable follow. So independent variable, X variable is independent, and then Y variable is dependent. So the dependent variable is the variable being predicted or estimated. So using sales core X variable, we can expect or predict Y variable, that is dependent variable. The independent variable provides the basis for estimation. It is the predictor variable. We call this one X variable as predictor variable. So using this predictor variable, X variable, independent variable, we can expect or predict Y variable. Correlation coefficient symbol is R. This one is a measure of the strength of the relationship between two variables. It shows the direction and strength. This correlation coefficient R has a plus minus sign, and then we can use this R, strength of a relationship. We can get that one. So this one, correlation coefficient R, using this formula, we can get sum of X minus mean of X, Y minus mean of Y variable. Each X variable, each Y variable, difference, each one, and then times, and then sum of them, and then divided by n minus 1. N is sample size, and then standard deviation of X, standard deviation of Y. This one between -1 and +1, plus minus 1. If R is 0, then there is no relationship. So we can get this from this R. If it is positive, then direction is this way. If it is negative, then direction is this way. So using this R, we can get the direction. If it is positive, X increase, then Y increase. If it is negative, then X increase, then Y decrease. X decrease, Y increase. And then with that value, closer to -1 or closer to the +1, strong relationship. Plus 0.9 it has a strong positive relationship between x and y variable. Negative 0.9, strong negative relationship between the two variables. About 0.5, plus minus, there is direction, but not strong. So we can say weak positive correlation, weak negative correlation. And then r equals 0, that means there is no direction. We cannot find any direction. So no correlation between two variables. And then this one, maybe we can find the direction from here to there, kind of positive, but from here to there, negative. Non-linear relationship between two. There is a relationship, but non-linear. Okay, example, number of cores and the number of copies sold. So we can see about this way direction. So using this formula, then I can get 0.759. Not very strong, but about strong relationship between copies sold and then number of cores. You may use a formula like this, but usually we use Excel or any program to get this one. So I will not go over this formula. And then using this correlation, we can, earlier we did framework. So which one is independent variable, which one is dependent variable, and then moderating variable, find, and then draw the chart like structure. If we have multiple data variables, then using this correlation analysis, we can draw that kind of structure, relationship structure. That is cause and effect modeling. Use survey the result to infer cause and effect relationship with the goal of improving customer satisfaction. In a marketing area, using this one, correlation analysis can help us develop cause and effect model, kind of a structure that relate lagging and leading measures. Lagging measures what happened, leading measures what will happen. So example, profit, market share, or customer satisfaction. That happen, and then that will happen. Employee satisfaction, productivity, and turnover rate. So using this data set, we can do it. Something like this. Okay. Then bring up data example. This one. So variables. First column is sample number, customer satisfaction, employer satisfaction, job satisfaction, satisfaction with the supervisor, training, and skill improvement. So before we use correlation analysis, just look at those variables. What do you think? training and skill improvement, job satisfaction, employee satisfaction, customer satisfaction. Maybe customer satisfaction, if job satisfaction is higher, then we may expect like an employee satisfaction high, then customer satisfaction high like this. So I can expect job satisfaction, employee satisfaction related, and then they are related to customer satisfaction. And then satisfaction with the supervisor maybe related correlation with employee satisfaction. Training and skill improvement maybe relationship with job satisfaction and employee satisfaction. So let's try using whatever. You may use Megastat, you may use the regular Excel data analysis, whatever. Let's use this data analysis. Then there is correlation here, correlation. And click OK. The input range. We don't need this survey sample. Include customer satisfaction or then all data at average. Then output range. Label in first row. And then output range about. I will okay. Here, among them, find the highest. This is R. So highest one is this one. So highlight. And the next highest is this one. And next one is this one. So employee satisfaction, highly highest correlation with employee satisfaction and satisfaction with supervisor. That is the highest correlation. And then next one is job satisfaction and employee satisfaction, training and employee satisfaction. Just like I expected. So using this, correlation, can draw relationship chart. So three of them with employee satisfaction with the three variables: job satisfaction, satisfaction with the supervisors, and training. They are related strongly with employees' satisfaction. And then last one, I expected employee satisfaction high, then customer satisfaction may be related, but not much. Anyway, positive relationship. So using this correlation analysis and cause and effect modeling, we can from this insight we can get something like a recommendation or suggestion. Improve customer satisfaction, the goal. Then improve satisfaction with the supervisor, improve job satisfaction, improve training, and then employee satisfaction, improve, and then not much, but positive relationship between this one and this one, like this. So this one, cause and effect model, we can use like set a strategic plan, or in research to develop the structure, the framework for our research using data, like this. So we can draw relationship chart like this. That's all. Very short. Lecture. And then I say always sorry about giving you assignment, but there is assignment individual. The purpose of giving you a individual assignment is just make you practice this one. So find the question and then data, and then try to develop this kind of chart using the data, using a correlation analysis. Okay, any question? You're too quiet. Quiet.
No question from here.
Okay, thank you.
Thank you, Dr. Kim.
You did this when you took data mining, right?
Yes, sir.
So you already know about this. So you're expert.
I'll try.
I don't remember what you did. Okay.
I have a question, Dr. Kim.
Yes.
So you want us to work on the assignment and then create the chart that was in your last slide.
Yeah, looks like that. Yeah.
Okay.
If you
All right.
don't know, then ask Chi.
Okay.
She is an expert.
I see.
Thank you.
Work together.
All right. Thank
Okay.
you, Dr. Kant.
Okay, good. Um, this morning I got an email from my friend. I submitted two research paper regarding coronavirus earlier. Then the first uh, paper we submitted about 2 weeks ago came back some as revision, so second revision stage. So we did already. And then this morning, second paper came back for a minor revision. So like that, yeah. So every week, like I said earlier, uh, whatever you do, okay, whatever you do, don't wait until last week. So part by part, complete. So if you did some part, then you can email me earlier than next class. Then if you give me time to review, or in class, show your work to class, then discuss together. Then maybe other team get idea from. So anyway, email me or show us every week what you did. So work together, work your team together, and then in class work all together like that. And then some part of the lecture. So next week I will cover linear programming parts. No, regression part. Linear regression part. Um, Linear regression part that in a research area for analysis data analysis. Uh, many cases we use that regression analysis. So next week I will cover that part. So if you have data already, then we may use your data. Or like in team one, your data for the regression analysis. Also, we can use regression analysis and then hypothesis tests for your team data.
Okay.
Mhm. And then other teams, I don't know if you have data yet. If you have data, then if you show me your data, then I will recommend what method use for your team data analysis. Okay. So until last class is presentation, and then one earlier last class will be review session. So until that time, finish one by one, complete one part by one parts, then work together, and then complete all parts until that time. Okay. Okay. Any question? Okay, tonight short class, but I gave you try to give you much. Okay, so see you next Monday, online only, and I hope you bring some your work. Okay, then work together, discuss together, and then I will cover regression part. Okay,
Thank you, Dr. Kim.
thank you. Anyway, I made 30-minute delay class, but next week go back to normal 6 o'clock. Okay, bye.
Bye. Thank you.
Thank you.
Thank you, Dr. Kim. Have a good
Thank
night.
you. See you Wednesday.
Yep.
Oh, yeah, Wednesday. Okay. Good night.